Welcome back. This is the second part of our series in mathematical language and symbols. So let's begin with mathematical expressions. In ordinary human conversations, we use words and phrases which suggest mathematical operations. The following common words and phrases indicate the mathematical operations of addition, subtraction, multiplication, and division. Words and phrases that imply mathematical operations. Let's begin with addition. In addition, we have these common words or phrases to mean that you need to add something or the operation is addition. You need to take note of this because we will be translating later mathematical verbal sentences or verbal phrases into mathematical symbols or expressions. So take note of these words. For addition, plus means addition. Increase by, that means added by. Total is also related to addition. When we say total, that means all the values were added to, more than, and the sum of. Again, these are the words and phrases that imply addition. Plus, increased by, total, added to, the sum of, and more than. The following are also words and phrases that imply subtraction. Minus, decreased by, fewer than, subtracted from, the difference of, less than. Words and phrases that imply multiplication. Times, the product of, multiplied by, and of. Words and phrases that imply division. Divided by, the quotient of, and per. Let's proceed to translating verbal phrases and their equivalent expression. This is what I said. Verbal phrases to equivalent mathematical expression. Example, the sum of a number and 5. Then you have, when we say sum of, that means addition. A number can be represented by or with a variable like n, and this 5 is surely the number 5. Therefore, that is, in mathematical expression, n plus 5. The next example is the difference of a number and 54. So you have a hint now. The difference of a number and 54. So difference of is a word or a phrase that imply subtraction. A number, we don't know what number is that. That means we will use a variable to represent it and then the number 54. In mathematical expression, we can write that as x minus 54. The next is the product of 10 and a number. Okay, so the word or the phrase product of. The product of imply multiplication. We have the value of 10 and again a number implies a need of a variable. So we choose x and therefore that can be written as 10x because you have the ability or you have the power to not write anything between variables that would mean multiplication. So 10x, that means 10 times of a number. Next is the quotient of 56 and a number. In mathematical expression, it is 56 divided by n because the quotient of represents or imply division. And this one-fifth of a number. So 1/5, 1 over 5, of means multiplication. A number can be represented by any variable, and this time we choose W. We have also what we call mathematical expression. A mathematical expression is a group of characters or symbols representing a quantity and slash or an operation. Okay, mathematical expression is a group of characters or symbols representing a quantity or an operation. Okay, this is clerical error. Next, an algebraic expression is a mathematical expression which contains numbers, variables represented by letters, and operations that indicate addition, subtraction, multiplication, or division. If you remember what mathematical expression it is, under it is an algebraic expression. Okay? So all algebraic expression is a mathematical expression. However, in algebraic expression, we have variables, numbers, and operations. That is algebraic expression. Next, translating verbal phrases into math expressions. So example, this time, so the previous examples that we had, they are just what? Simple mathematical expression which do not contain operations. But this time we have algebraic expressions. Okay, mathematical expression still. So verbal phrase, 3/4 of 500 pesos. So 3/4 of is a multiplication, and 500, you can write it as 500. So 3/4 times 500, that means 3/4 of 500. This one. That verbal phrase can be translated. Why do we need to write this operation? Yes, because we mean that we need to multiply it. Or if you will not write the operation, it can be misinterpreted as 500 and 3/4. That means when you mean this one and you cannot find any variable, you should write the operation. Okay, this time it's multiplication. You can also use open and close parentheses to mean multiplication. Next, the sum of two numbers less 11. So in mathematical expression, we can write that as, take note, the sum of means addition of two numbers. Since you don't have the actual two numbers, you will be using variables to represent them. And this time, we choose x and y. So x plus y, because this is the sum of, and less means minus 11. So close and open parentheses to mean that you group them x plus y because sum first before it will be subtracted with 11. Again, because it is emphasized to be the sum of two numbers, or else you will say a number is added by another number and subtracted with 11. Okay, but this time it is emphasized that the sum of two numbers, so you need to add them first before you subtract it with 11. 30% of selling price. Okay, selling price is unknown, so that means we need to represent it with a variable. 30% is given. But we cannot solve 30% immediately in this operation unless you are using a calculator. So that means you translate 30% into decimal form and then put the selling price variable, which is X. When you are using this one, you need to declare what is your variable means. What your variable means, like where X is the selling price. Double the quantity of sales less taxes. So without looking at the solution first, double the quantity. That means double the quantity. So 2 times the quantity is unknown, so you must use a variable. Okay, so in this example, we use Y is sales and T taxes. So double, that means 2 times the quantity minus the taxes, where Y is sales and T is taxes. Next, the difference of gross sales and total cost. The difference of is subtraction, gross sales and total cost are unknown, and therefore they should be represented with a variable. So Y minus C, where Y is gross sales and C total cost. Let's proceed with mathematical sentence. A mathematical sentence is a mathematical expression which is either true or false. We call that mathematical sentence. Expression which is either true or false. With this in mind, the expression 25 plus 1 equals 26 and negative 4 minus 5 equals 9 are both examples of a mathematical sentence, although 25 plus 1 equals 26 is true and the second is false, which is negative 4 minus 5 equals 9, because that would be, and that should be, negative 9. A mathematical sentence which is true or false depending on the value of unknown quantities is called an open sentence. Okay, I will show that later. Open sentence. Thus, x minus 5 equals 20 and x squared minus 10x plus 25 equals 0 are examples of open mathematical sentences. When can we say that a mathematical sentence is open? When it is true or false depending on the value of the unknown quantities. In this example, we have x. A closed mathematical sentence is one which is known to be either true or false. The sentence x squared plus 1 equals 0 has a solution in the set of real numbers. Is a closed sentence because it is false. So take note, open sentence, true or false depending on the value of the unknown x. However, when we say closed mathematical sentence, which is known to be either true or false. So you can really say that it is true, and you can really say that it is false. That is closed mathematical sentence. So example, x squared plus 1 equals 0 has a solution in the set of real numbers. That is a closed mathematical sentence because the statement is false. There is no solution in the set of real numbers for x squared plus 1. Why? Because it's square root of negative 1. And there is no solution for that. We cannot enclose, or I mean, we cannot have a negative number inside a radical sign. Next, let's proceed with mathematical sentence still. A mathematical sentence which is true or false depending on the value of unknown quantities is called open mathematical sentence. So when you substitute a value to any of the variable or the unknown quantities, whether it becomes true or false, that makes the mathematical sentence open. But when you are referring to a closed mathematical sentence, it is one which is known to be either true or false. So it is there already. You just need to identify if it is true or if it is false. And if you can decide whether it is true or false, it's already a closed mathematical sentence. You don't need to find the value. I mean, you don't need to find or to put a value to the variable. As long as when you read it, you can say that it is always false or it is always true. That is already a closed mathematical sentence. Mathematical equation. A mathematical equation, or simply equation, is a statement of equality between two algebraic expressions which contain one or two unknowns. Again, a mathematical equation, or simply equation, is a statement of equality between two algebraic expressions which contains one or two unknowns. So it is also customary to speak of the left or right sides of an equation. They are often labeled with acronyms LHS, the left-hand side, and RHS, the right-hand side. Unknowns are represented by letters, often in lowercase, called literal variables. So the unknowns in the mathematical equations, we call them literal variables. So here it is, left-hand side, right-hand side, and the literal variables. Now let's try to translate verbal sentences into mathematical sentences. When we say verbal sentences, it has verbs. So that means mathematical sentence also must have verb. And the only verb that we have in mathematics is the word is. Okay, so let's begin with this example. 10% of sales is 5,450 pesos. So in our previous example, we have only an expression like this, but this time we have mathematical sentence. Sorry, I should have changed this into mathematical sentence. So 0.10x equals 5,450. That is already a mathematical sentence. Why? Because it has the equality symbol here. Don't forget to write the declaration of your variable where x represents sales. Example number 2, gross sales less taxes is 7,560 pesos. We can write that as x minus y equals 7,560, where x is gross sales and y taxes. Really don't forget this declaration of your variables. Third, my father's monthly salary is twice what my mother makes in a month. Their combined monthly salary is 27,000 pesos. So the mathematical sentence for that is a piecewise function. You declare x equals 2y and x plus 2y equals 27,000. This set of equation is called a system of equations. In particular, it is a system of two linear equations into unknowns. What do we call this one? System of equations. Okay? And in particular, we call them as two linear equations into unknowns because what are the unknowns? X and Y. So we are dealing with mathematical language and we are now in mathematical sentence whose verb is and is represented by the equality sign. The average of two quizzes is 85. The first quiz is 10 points higher than the second. So we are still using this one system. And for the Yeah, x plus y divided by 2, that is to get the average of the two quizzes. The scores are represented by x and y to the divisor to get the average, which is 85. The first quiz, which is x, is 10, yeah, y, 10 points higher than the second. So 10 plus y. So the first quiz is 10 points higher than the second. That means 10 plus y equals x. So the second is y. And if you add 10 to that, that will become the first score. So what do you need when analyzing or translating verbal sentences? It should be logically and syntactically right. Diba? So you must keep your thoughts focused, and I would like to encourage you to think critically in translating verbal sentences or verbal phrases into mathematical expressions or mathematical sentences. Why? Because you need to analyze this. You cannot simply put it this way unless you are thinking critically and you know what you are doing. So when you are prompted with um, a problem where two equations should be derived, that means you make a system of equations. Okay, this is still two linear equations. With two variables, linear equations with two variables, because we have two unknowns, which are x and y. Now let's have these examples. Find examples because we have another example below. Find the minimum exam score to pass. So you might be wondering, what should be my final examination score so that I could pass this subject? Okay, so let's try. To pass the course, a student must achieve a general average or arithmetic mean of 75 points in three major subjects or major exams, sorry. Miss Miriam Grace Malabanan scored 70 and 65 in the first two exams. What minimum score must she get in the third exam to pass the course? So, while reading this, you should have something in mind or um, prediction. What is the possible? So, 75 and all of these two previous exams, Miss Miriam fails 70 and 65. Pila dapat akong pwede ka magbana-bana like 70 kulangan og 5, ang 65 kulangan og 10, dapat iyang score sa final is pila? 15 man ang kulang. Dapat makascore siya og 75 plus 15. 75 plus 15 plus 85 plus, so dapat maka 90 siya. Tama ba kaya atong bana-bana? Okay? So, ingana magbana-bana, and we need that prediction so that we can check or evaluate our solution if it is really correct. So, the solution is let xi, unsa man na ma'am, ngano man ha, daghan kay number, okay? Let this xi represent Miriam's score in major exam. X sub 1 is 70 and X sub 2 is 65. We lack X sub 3. To pass, her average X for three major exams should be at least 75 points. Okay? To pass. So, her average should be at least 75 because, you cannot pass a course without having 75. So this is the example of arithmetic mean. The symbol x bar equals summation because we need to add first, second, and third. Okay, this is the first value of I and the last value of I tapad sa summation. We need the 3 because tulo sila i-divide para makuha nimong average. X sub 1 plus X sub 2 plus X sub 3. So let's take a look at solve for X. Pila ganito tong bana-bana? 90. Uy, 90 jud ang naadiri ah. Okay, so the arithmetic means equals 70 plus 65. What are these? These are the values of your X. X sub 1 is 70, X sub 2 is 65 plus X sub 3 over 3. It should be greater than or equal to 75. Because lesser than this, she cannot pass the course. So we need to find X sub 3. So X sub 3 should be greater than or equals 3 times 75. Ma'am, asa man na nimo gikan? Sige, kaning X sub 3, ibalhin nimo dire. Tapos, kani siya, ibalhin nimo dira. Ang kaning 3, i-multiply nimo sa 75. And since these are given values already, we need to subtract it to the average. So, 3 times 75, that is 150. Ang duha ka 75. So, that means ang tulo ka 75, 225. Minusan nimog 70, pila na lang? 155. Minusan nimog 65, 90 na lang. Okay? So, that means Miriam must score at least 90 points in her third exam to pass the course. Asa nigikan? This one. Asa nigikan? Dire. I-multiply nimo ani, imuhang cut off. And then kani, i-minus dira, i-minus dira. Okay? If you cannot work with this mathematically, then you can solve this tinambali. Tinambanli. Unsa na tinamban, ma'am? Kanang binisaya nato na pagka-solve like bana-bana or walay proper mathematical expression pero you can solve it, you know it. Okay? So, that is how to find the minimum exam score to pass a course. The next example is find the numbers. Example, the sum of two integers is 76 and their difference is 2. What are the integers? Again, the sum of two integers is 76 and their difference is 2. What are the integers? Una-una din ka. Unsa man na ha? 76 dapat silang duha. Dapat tunga. Katunga sa 76. Tapos, ang isa mas dako og duha kaysa sa isa. Okay, so dapat nakay bana-bana, mga 30 gini siya kapin. Okay, tunga, kay dapat kung i-add na ko sila, makakuha mo ko 76. So I know you have your answers there, but let's take a look with the solution. So, let x and y represent two numbers because we don't have variables for them, y being the greater and x the lesser. Their sum is 76 and their difference is 2. Money siya. We can write this as a system of two equations in two unknowns. So, x plus y equals 76, y minus x equals 2. So, how to solve it? We can solve this either by substitution, elimination, or even graphical method. But this time, we will use substitution. So, let y, okay, kaning y nato, himuon natong x plus 2. Nga naman, ma'am? Para makasubstitute ta. So, we need to find variable na atong i-dissolve para makasolve ta. So, i-dissolve na to ang y. So, y, balhin ang x sa right. Okay, but class, it's not really that transposition thing. It's addition property of equality. You add x here and you add x to the other side. That is y equals x plus 2. Kaya makancel naman na siya. Okay, so maunang y equals x plus 2. So, to solve for x plus y, and this time our y is x equals 2, x plus 2. So, x plus 2 equals 76. X plus x is 2x. Then you copy the 2 equals 76. What shall we do with this? So 2x combine like terms. So we shall still apply that. 2x equals 76 minus 2. Okay? Why minus? Because subtraction property of equality, in order to eliminate this in the left side, you need to subtract it with 2. Subtract it with 2. What's the next step? Okay, after subtracting it with 2, you need to divide both sides with 2. Ma'am, di na namo na siya masabtan. Let me try if I can show you using a blackboard here. Screen, pointer in color. Right click, screen. I cannot make a white or black screen for recording. Basta the next step is this will become 2x equals 74, and then 74 divided by 2, that is x equals 37. Therefore, since y equals x plus 2, so 37 plus 2 equals 39. The numbers are x is 37 and y equals 39. Okay? So I hope you get that. If you have your ball pens and notebooks while I'm discussing this, I hope you have written it.